Can AI play a role in operational and efficiency gains for data centers and for the whole energy system? If we are honest, currently AI story starts more with an energy shock than an energy efficiency story. It's consuming currently about 500,000 terawatt hours of power globally, and is projecting to double to 1,000 terawatt hours by 2030. That's basically Japan. So it's not really an efficiency story. And we look and we ask to executive in the energy and AI data center industries. And they all expect that to grow, but more importantly, to become more volatile across the time. And that's what adding a lot of stress to the system. But on the other side, if you look at the, I would say, positive benefits of AI, that's also probably the only technologies that we have that can solve this complexity that we didn't have yet. So it can predict better demand, it can help to forecast consumption, it can also help to adjust the production and to match those two with a very distributed system that we have currently with all the energy sources and consumption there are. And that's not a theory, it's fact. We all see today that there are companies that currently are using those technology to shift loads to when there is more power available, that are using it to redesign the way that they use energy. And it's significant. We are talking tens of billions of savings. And according to the International Energy Agency, that's also a massive amount of equivalent to energy infrastructure that we don't actually have to build because of AI or thanks to AI. So yes, it's adding more demand, but it's also, I would say, the only solution to answer its self-growth. So when you think about innovation to reduce energy or water usage in data centers, you usually think of better technology, better cooling, better computing system, but actually what we are seeing is that it's a combination of all of that, the system thinking that makes it really innovative. And there's several layers to address. First, the cooling. Cooling is usually where technology meets water meets scarcity, where power meets scarcity. And we are seeing currently a lot of innovation to improve cooling, reuse heat, for instance, to produce efficient cooling system so that you consume both less power and innovate in the cooling system to reduce the amount of water. We even see some data centers that are using almost no water in their design. The second is a bit less visible. It's about shifting loads, and it's basically using AI and innovative platform to decide when you want to do a calculation depending on the availability of power, so that you can anticipate and reduce and in fact design not for maximum load consumption, but design for something more efficiently. I've met a company last week who does exactly that. They shift loads for data center operator based on the availability of power, but also its carbon content and or its price, depending on the, I would say, arbitrage that the company is designed to make. The other one is chip design. We see that in chips, you can completely optimize the design. So there are new companies that are now trying to solve that problem to reduce the amount of power that they use during computation by a completely new design in the silicon of the chip itself. So that's also more hardware innovation, but that's bringing a lot of reduction of usage. And there's a fourth domain, which is water reuse. Obviously, there's a lot of circularity that you can do in water. First, you can use reusable water instead of clean water, and you can integrate closed loop systems in your data center design so that you reuse and you the maximum of water in the data center to completely reduce the water stress under which you would be constrained depending on, I would say, permit or administrative constraints. So the big innovation is to consider all of that together: compute, water, load switching, and circularity to make the data center as efficient as possible right from the design and not only after it's operating.